Hello everyone. Previous class just stopped in between, and like thing was that I can't record the video more than 10 minutes. So because of that reason, I believe it ended somewhere like it was about to complete. So I'll just explain you what we have done. So here, what we have done here, we have opened the bracket. Let me first discuss whatever we have done. So here first what I have done, I opened the bracket. So once I open the bracket, then this and this will get cancel each other, and once this and this will get cancel each other, after that what I have done, after that once you will get cancel this. So ultimately we left with the alpha of the active portfolio divided by this relation. So in that relation, what left with you, what I have done, mu- I have cancelled the variance of the market. I have cancelled the variance of market from both numerator and denominator. You can see variance of market is there in both numerator and denominator. So I cancel the variance of market by both numerator and denominator. So ultimately, I got this relationship. So ultimately, I got this relationship once I cancel the variance of the market. Once I'll cancel the variance of the market, I got this relationship. So what I'll do, I'll continue my session from here. I believe whatever I have done, you would have understood till now. It's just nothing but we are what we are trying to do. We have started our class with the optimal weight formula under the composition that we can maximize the Sharpe ratio, and then we are just substituting the values. We are just substituting the terms, like whatever the terms which are required for us. We are substituting the terms, like in place of excess return on active portfolio, I have written alpha of the active portfolio plus beta of the active portfolio into return excess return on the market. In place of covariance between active portfolio and market, I've used this formula, and in place of variance of active portfolio, I'm going to use this formula. So we are just deriving the one end of the formula from the other end. Clear, right? So I believe you are understanding whatever we are doing. So we are just let continue after this. So so once so further to this, when we work on what we need to see. So further to this, what we have worked on. So we have multiplied the variance of market with both numerator and denominator. So once we multiplied the variance of the market with both with both numerator and denominator, once we got this relationship, what I can do, so I can write the weight of the active portfolio, as the alpha of the active portfolio divided by the, so alpha of the active portfolio plus beta of the active portfolio into excess return on the market plus excess return on the market into again this is the variance. This is the, so this is the variance uh, of the active portfolio. This divide by the variance of the market minus, if you open the bracket, you will get is alpha of the active portfolio into beta of the active portfolio plus, sorry, minus beta square of the active portfolio into return on market minus beta of the active portfolio into return on market. So you will get this. Clear, right? So once you get this relationship, so once you get this relationship, so we have to continue further from here. So you get this relation, let me write it somewhere so that I get to know that from where I'm ending. So this is alpha of the active portfolio into alpha of the active portfolio plus beta of the active portfolio into return excess return on the market plus return on the market into standard deviation of the active portfolio by variance of the market minus alpha of the active portfolio into beta of the active portfolio minus beta square into return on market minus of beta of the active portfolio into return on the market. What you can notice from here, that this and this is common, so you can cancel this, so no need to write it in the next step. So this and this can get cancelled. Clear, right? So what I'll do, I'll open a new blank sheet. Okay, so I'll write from here. So weight of 1 is equal to the alpha of the active portfolio, this all divided by the, I can take alpha of the active portfolio common. So if I take common, I left with 1 minus beta of the active portfolio, this and this get cancelled, plus a return on the market into the variance of the active portfolio divided by the variance of the market minus of beta square of the active portfolio into RM. So so 1 minute, so let me cross verify. So alpha of the active portfolio by alpha of active portfolio, this and this I have taken common, then you have written this RM into variance of the active portfolio by the variance of the market minus beta square of the active portfolio into RM. So what you can do further, so you can write W1 is equal to alpha of the active portfolio divided by the alpha of the active portfolio into 1 minus beta of the active portfolio plus RM into variance of the active portfolio minus variance of the market into beta square of the active portfolio into RM divided by the variance of the market. 1 minute, let me see the time, how much time. So still 7 minutes is there. Fine. So we have done till here. Now what you can do, now it's the time that you can substitute the value of the variance of the active portfolio. So what you can write weight of 1 is equal to the alpha of the active portfolio divided by the, so you can write this alpha of the active portfolio into 1 minus beta of the active portfolio plus 1 minute, plus, now what I can do, in place of variance of the active portfolio, I can write this as the beta of the active portfolio into variance of the market plus unsystematic risk, that is your residual variance, this minus RM into variance of the market into beta square of the active portfolio, this all divided by the variance of the market. Fine. Now what you can do, now after this you can write that the alpha of the active portfolio, so this is alpha of the active portfolio 1 minus beta of the active portfolio, you can open the bracket, that is RM into beta RM, so this would be beta square, so RM into beta square of the active portfolio into variance of the market plus RM into residual variance minus RM into variance of the market into beta square of the active portfolio divided by the variance of the market. So this and this will get cancelled.